And I'm going to use this rule, okay? So can you guys get this rule down? How you say it? Alpha. Okay, so what? Okay, so if you want to look at the example that we have here, okay, that's your example. I want to differentiate that. If you want to make a connection with this, okay, Rupa, what do you think G would be? And Solomon, what would H be? Yeah, help him out. Rupa, help him out. Keep him on task. Keep him honest. Sin x, okay? So I'm going to differentiate this function. So look what I do, okay? I keep sin x constant and I differentiate x. You guys with me on that? So then f prime of x is going to be, what's the derivative of x? 1. So it's going to be 1 times sin x. Okay? Plus, now I'm going to keep g constant, which is x, and I'm going to differentiate sin x. What's the derivative of sin x? Sorry? Cosine x. And that's your answer. That's your answer. Okay? Do not write this as cosine x, x. That's pretty ugly. Because do you mean cosine of x squared? Okay, so that's kind of ugly. Put the x in front of the cosine. Okay? Is everybody all right there? Nikhil, yes, no? Okay, let's do some examples and get you practicing these things, okay? So it works for even more products, okay? So it doesn't have to be just 2 functions. It could be a whole bunch of functions, okay? And the same rule kind of applies. It's not too different. So, what? Complex number? Oh, my bad. Right, so what I want is I want f prime. So look at the rule, okay? It says keep the last 2 functions unchanged, differentiate the first one. So here's 1, 2, and 3. So differentiate the first one, what do you get? What do you get if you differentiate x? 1. Leave the others alone. Okay? Now, leave the first and third alone and differentiate the second. So it's going to be x. What's the derivative of sine? Cosine. So then, do you see how it becomes cosine squared x? Do I need to explain that? You guys see that? Okay. And then for the third one, keep the first 2 constant and differentiate the last. Derivative of cosine x. Negative sine x. Nice. Good job. So this becomes sine x cosine x plus x cosine squared x minus x sine squared x. Now you can simplify this, okay, using trig identities. You can simplify this using trig identities. And, you know, I'll do that for you, but if you can't do it, that's okay, because it really means you got to know your trig identities. You can bring that sheet in, right? The trig identity sheet. So let's just go. So I would suggest you get that sheet out so you know what I'm talking about. Okay, or it's at the front of the book. So the first term here, I'm going to write it as 1/2 sine 2x. Can everybody look at the double angle formula and make sure you've got that connection there? Does everybody see where to go? Double angle formula. It says sine 2u is equal to 2 sine u cosine u. So instead of u, we've got x. Okay? So if you divide by 2, that's where the half comes from. Is everybody with me on this? You can only be with me if you've got the identity in front of you. If you don't, you're lost. You're doing sine 2u, double angle, equals 2 sine u cosine u. Found that? then this one here, I'm going to first factor out the x, and I get cosine squared x minus sine squared x. And you guys go look for an identity that tells you what cosine squared u minus sine squared u is. It's in the general vicinity or where you saw the first one. Cosine 2u. Is everybody there? Okay, so except it's not cosine 2u, it's going to be cosine 2x. Right? Because they use u, we've got x. Is everybody okay on this stuff? Okay, I mean, if you can't go from here to here, I'm okay with it. Okay. Right. In the AB class, that would not be okay. In the AB class, you'd have to know how to do this. All right? Is everybody okay? Ryan, got a nice smile on you there. Hopefully, it's a mathematical smile. Kind of feel this in your heart. Oh, I see. Ah. Okay, you guys do this one. You know what, let me go into the quotient rule and then I'll have you do some more of this. So, if you have a product rule, then you need a quotient rule, right? Multiplication and division, they all kind of go together. So, here's an example where now I need a quotient rule. Okay, I need a quotient rule. Okay, and so here's the rule. It'll look really complicated if you see it, but when we do it, it's going to be fairly easy. Okay, when we do it, it'll be fairly easy. Which it's done, okay? So for the quotient rule, you keep the denominator constant first, differentiate the top, minus, keep the top, differentiate the bottom. Okay, all over bottom squared. Okay, maybe you want to write this in words. You know, I mean, if these symbols don't mean a lot to you, you might want to write it in words, okay? So let's go apply that rule to this example then, okay? Okay, so I want f prime of x. So again, I'm going to keep the bottom, differentiate the top. So bottom is x, differentiate sine x. What do you get? Cosine x. Differentiating sine gives you cosine. Okay. Minus, keep the top, differentiate the bottom. So the top is sine x and derivative of x, 1. And then you're going to square the bottom. And really, you can't simplify this any further. I mean, this is really the end of the line. There's not much you can do. If you really want to do some simplification, you could write it as this. Okay. But you could stop here, and I'm okay with that. All right, you guys get the quotient rule? Yeah. Yeah? Okay, let's do a couple of more examples. Okay, so you guys do this one now, okay? I've just flipped it for you now. Okay, jazz it up and you guys do this. So now you've got a product and a division, okay? A product and a quotient. Yeah, you have a product at the top, and then you also have a quotient. Sorry? Why? I mean, this stuff is, wait till you do some of the problems in the book, man. Yeah. Okay, hang on.